to my YouTube channel. So kung bago ka pa lang po sa aking channel or napadaan lang po kayo, please subscribe po and please click the notification button para at least updated po kayo sa aking mga video na ina-upload when it comes to mga subjects sa civil engineering na kurso, no? And please like na lang din po ng video, no, kung sakali, or either ako na lang ang i-like ninyo kung ayaw niyo ng video, no? Joke lang po yun. Okay. So for today's video, I will be discussing application of earthquake load to the design of a square and rectangular footing. Earthquake is defined as the ground shaking caused by sudden release of energy of Earth's crust, no? Kung baga, kapag si Earth ay magre-release ng enerhiya, ay magkakaroon po ng ground shaking, no? Na kung saan ay yung mga structure natin at yung mga buildings na tinatayo natin bilang isang civil engineer ay nakalagay sa lupa, at once na magkaroon ng movement yung lupa, magkakaroon din ng movement yung ating building and yung ating structure. And once na magkaroon po ng movement yung ating structure, magkakaroon po ng stresses na mangyayari doon, no? And ayaw po natin na stress, no? Kaya bilang isang civil engineer, we should always consider all the possible loads na i-carry ng ating structure, especially yung mga dead load, live load, wind load, earthquake load, no? Kasi kailangan yung ating structure ay resilience or resistant sa mga bagay na yon. For example, dumaan man yung malakas na bagyo, magkaroon man ng baha, or magkaroon man ng malakas na earthquake, at least yung ginawa natin o yung dinesign natin na building ay kaya pa rin mag-withstand, no? Or nakatayo pa rin siya, hindi siya nasira, no? So for this video, I will be showing you kung paano i-design ang pundasyon na square and rectangular, no? Para na considering earthquake load. And disclaimer po agad sa mga nanonood ng aking video, kumbaga itong video na to ay for educational purpose, and I'll make sure na sana matuto kayo, no? Kumbaga, I will be discussing it as much as possible na maiintindihan ng estudyante, lalo ngayon pandemya at medyo nahihirapan po yung ibang estudyante mag-cope up sa mga subjects, especially sa major subjects nila. And disclaimer po ulit, ito ay mahaba agad yung solusyon kasi square lang po muna ang pag-uusapan natin, hindi po muna tayo magre-rectangular kasi for this video ay sigurado ako mahaba ang solusyon dito and mahirap pa kasyahin sa board, so I'll make sure na maintindihan nyo nga itong discussion natin, no? So I will be showing you a video clip first para makita ninyo kung ano yung effect ng earthquake sa ating structure, at as well as makikita ninyo ang kahalagahan natin bilang isang civil engineer. So mahalaga tayo, guys, kaya huwag kayong papatalo, no? So mahalaga tayo bilang isang civil engineer sa mga structures na ating tinatayo. Okay?
Earthquakes have always been a terrifying phenomenon, and they've become more deadly as our cities have grown, with collapsing buildings posing one of the largest risks. Why do buildings collapse in an earthquake, and how can it be prevented? If you've watched a lot of disaster films, you might have the idea that building collapse is caused directly by the ground beneath them shaking violently, or even splitting apart. But that's not really how it works. For one thing, most buildings are not located right on a fault line, and the shifting tectonic plates go much deeper than building foundations. So what's actually going on? In fact, the reality of earthquakes and their effect on buildings is a bit more complicated. To make sense of it, architects and engineers use models, like a two-dimensional array of lines representing columns and beams, or a single line lollipop with circles representing the building's mass. Even when simplified to this degree, these models can be quite useful, as predicting a building's response to an earthquake is primarily a matter of physics. Most collapses that occur during earthquakes aren't actually caused by the earthquake itself. Instead, when the ground moves beneath a building, it displaces the foundation and lower levels, sending shock waves through the rest of the structure and causing it to vibrate back and forth. The strength of this oscillation depends on two main factors: the building's mass, which is concentrated at the bottom, and stiffness, which is the force required to cause a certain amount of displacement. Along with the building's material type and the shape of its columns, stiffness is largely a matter of height. Shorter buildings tend to be stiffer and shift less, while taller buildings are more flexible. You might think that the solution is to build shorter buildings so that they shift as little as possible. But the 1985 Mexico City earthquake is a good example of why that's not the case. During the quake, many buildings between 6 and 15 stories tall collapsed. What's strange is that while shorter buildings nearby did keep standing, buildings taller than 15 stories were also less damaged. And the mid-sized buildings that collapsed were observed shaking far more violently than the earthquake itself. How is that possible? The answer has to do with something known as natural frequency. In an oscillating system, the frequency is how many back and forth movement cycles occur within a second. This is the inverse of the period, which is how many seconds it takes to complete one cycle. And a building's natural frequency, determined by its mass and stiffness, is the frequency that its vibrations will tend to cluster around. Increasing a building's mass slows down the rate at which it naturally vibrates, while increasing stiffness makes it vibrate faster. So in the equation representing their relationship, stiffness and natural frequency are proportional to one another, while mass and natural frequency are inversely proportional. What happened in Mexico City was an effect called resonance, where the frequency of the earthquake's seismic waves happened to match the natural frequency of the mid-sized buildings. Like a well-timed push on a swing set, each additional seismic wave amplified the building's vibration in its current direction, causing it to swing even further back, and so on, eventually reaching a far greater extent than the initial displacement. Today, engineers work with geologists and seismologists to predict the frequency of earthquake motions at building sites in order to prevent resonance-induced collapses, taking into account factors such as soil type and fault type, as well as data from previous quakes. Low frequencies of motion will cause more damage to taller and more flexible buildings, while high frequencies of motion pose more threat to structures that are shorter and stiffer. Engineers have also devised ways to absorb shocks and limit deformation using innovative systems. Base isolation uses flexible layers to isolate the foundation's displacement from the rest of the building, while tuned mass damper systems cancel out resonance by oscillating out of phase with the natural frequency to reduce vibrations. In the end, it's not the sturdiest buildings that will remain standing, but the smartest ones.
Okay, so kung mapapansin po ninyo yung nangyari sa video, si earthquake is yung sudden movement nga ng lupa natin sa ilalim, and once na magkaroon po ng movement yung lupa natin, is possible magkaroon din ng effect sa ating structure, causing fatal, no, na kung saan pwedeng masira yung ating structure once kapag hindi natin siya na-consider. So bilang isang civil engineer, ang trabaho natin is to make sure the safetyness of the user, as well as yung pagiging resilient ng ating structure na ginagawa, no, or pagiging matibay ng structure. So bilang isang civil engineer, we should always consider the possibilities na magkaroon ng earthquake sa bawat structure na ginagawa natin. So we always need to consider those earthquake loads kapag tayo ay nagde-design, no. Pero syempre, usually naman kapag sa actual condition na rin naman, kasi staad na ang ginagamit, yung may mga design software na, may mga spreadsheets na ginagamit para sa pagde-design. Pero for you bilang isang estudyante ng civil engineering and you need to take board exams, so kailangan nyo mag-gets or masundan tong principle kung paano siya dine-design, no. And also binanggit din dun sa video na kung saan hindi porke mahaba yung building or maliit yung building ay okay na, di ba? So it depends pa rin sa mga sa mga factors na pwedeng mangyari during earthquake. And also sinabi naman dun sa video na kung saan ay para ma-prevent natin yung pagkasira ng ating structure sa due to earthquake is we need to match the frequency of yung movement, no, yung possible movement ng lupa. So kapag na-match po natin yung frequency ng movement ng lupa sa frequency ng ating building, so mag-withstand siya, no. And also binanggit din dun sa video na kung saan it's not the sturdiest buildings that withstand, no, it's the smartest one. Kumbaga hindi sa palakihan, so sa maliit man yan or sa pagandahan ng ating structure. It depends dun sa kung paano natin dinesign yung ating structure. So if you consider the possibilities na magkaroon ng earthquake sa ating structure sa pagde-design ninyo, so magkaroon man ng earthquake, ibig sabihin mawi-withstand niya. So pero kung hindi mo siya kinonsider, possible masira yung ating structure, no? So these are the steps on designing a footing considering earthquake load. So halos pareho lang din po siya ng steps nung actually loaded columns na actually loaded footing natin. So ang pinagkaiba lang po ay meron tayong 6m over BL squared, no. Kumbaga ito yung formula for flexure, no, stress, flexural stress. Kasi di ba si force over area is just a normal stress. So kapag yung load is actually loaded lang, normal stress lang po ang nangyayari sa ating pundasyon. But if there is a moment, no, magkakaroon ng flexural stress din dun sa natin sa structure. Kaya nga meron ditong additional 6m over BL squared. So kung square ang pinag-uusapan natin, magiging b cubed na lang po to, no. Then again, after natin makuha yung value ng dimensions, assumed dimensions dito, ng dimension dito sa gamit yung QA. So makukuha natin yung assumed thickness, no. So HC. After natin makuha yung assumed thickness, we will be getting the effective soil pressure QE by kumbaga yung allowable soil pressure minus natin yung mga other pressures, no, like yung unit weight of soil, height ng soil minus unit weight of concrete, height ng concrete. Then after natin makuha yung value ng effective soil pressure, so we could get the actual dimensions of footing by using the QE or the effective soil pressure dun sa formula natin, no. And after natin makuha yung actual dimensions ng ating pundasyon, we could proceed to step 2, which is determining the thickness of the footing, no. In determining the thickness of the footing, we should always get the ultimate soil pressure, no. So kumbaga ultimate yung natin, soil pressure natin. Kumbaga naka-factored yung loads, lahat ng loads is should be factored. So we have here QU, or the ultimate soil pressure, is equivalent kay factored force P all over the area plus 6 factored moment all over BL squared. And after natin makuha yung value ni QU, we could get the value of D, or the effective depth, by computing it into shear, one-way shear and two-way shear. Si one-way shear is, the formula for one-way shear is VU is equivalent kay PBC, and for two-way shear is equivalent kay VU is equivalent kay PBC din. But ang pinagkaiba lang po dyan is yung VC, no. Kapag pinag-uusapan natin si one-way shear, ang VC po natin is, or the nominal shear po yan is 0.17 lambda square root ng F prime C BWD. And for two-way shear, we have here 0.33 lambda the square root of F prime C BOD. But kung mapapansin, kung nagbabasa po kayo ng NSCP 2015, there is hindi lang siya 0.33 lambda. Meron pa yung may mga beta, at actually tatlo po yan, no. Tatlo siya na VC. But I use this 0.33 VC kasi ito usually yung nagbibigay ng malaking value. Kasi nga, pagdating naman sa provisions, sasabihin lang naman sa iyo, papapiliin ka lang naman kung saan yung may pinakamalaking value. Yun yung gagamitin mo. So, I prefer na gamitin na agad yung 0.33 lambda, no. But for the sake, kailangan nyo din i-consider yung iba kasi nga, especially may naka-identify dun sa ating provisions, lalo na kung interior column ba or interior ba yung foundation natin or sa exterior, no. Then for step 3, we will be getting the steel requirements, no. After natin makuha yung dimension, tapos nakuha na natin yung effective depth or yung thickness ng ating pundasyon, we could proceed to getting the reinforcement, no, na kung saan ay itong reinforcement na to, ito yung magre-resist ng tension sa ating pundasyon, no. So by using the formula, mu is equivalent kay VRUBD squared, no. So itong mu equivalent kay VRUBD squared is formula din to sa RCD, no. Then para makuha natin yung steel requirements, so we need to get the value of rho, no, by the formula 0.85 F prime C all over Fy multiplied by 1 minus the square root of 1 minus 2Ru over 0.85 F prime C. And this rho will be kumbaga i-compare mo sa rho minimum and sa rho max. And the condition should be rho minimum should be less than rho and rho should be less than rho max, no. Ibig sabihin, kapag si rho min ay mas malaki kay rho max, use rho min. And kapag si rho is mas malaki kay rho max, use rho max. At kapag yung condition naman na binanggit ko na si rho min is less than rho and rho is less than rho min, ay rho max, use this value of rho, no. So para makuha natin yung area required, so we have here AS is equivalent kay rho BD. And for the number of bars, yung total number of steel requirements divided by the bar diameter na binigay dun sa problem para makuha mo yung total number. And for the spacing, we have here the dimension minus 150 all over number of bars minus 1. Yung 150 po dyan is yung 75 magkabila ang side nung pundasyon kasi hindi naman sagad yung ano natin, yung bakal, no. So we need to have the concrete cover first. Okay? So let's proceed to sample problems of a square footing with bending moment. So we have here this sample problem. Design a square footing supporting 400 mm by 400 mm square column with 12 pieces of 20 mm main bars. The column footing is to resist a load from a column service dead load of 600 kN and a service live load of 300 kN. The designer also considered the earthquake load to resist a moment dead load of 120 kN and a moment live load of 75 kN meter. The base of the footing is located 3 meters from the natural grade line. The following are soil investigation data gathered by the geotechnical engineer. So, unit weight of soil is equivalent kay 18 kN per meter cube and the allowable soil pressure is 300 kPa. Consider F prime C is 27.5 MPa and Fy is 415 MPa. Use NSCP 2015 and use concrete cover of 75 mm. Use 20 mm diameter bar for the footing rebars. Okay? So, let's proceed on computation tayo. So we have here this figure na kung saan ay binigay na kanina dun sa problem, no? Ito. Kung makikita niyo diyan, itong figure na to is nilipat ko lang siya dito. So we have here this column na 400 by 400 mm and we have this load na i-carry ng ating column which is dead load of 600 kN and the live load of 300 kN. We also considered earthquake load which is 120 kN dead load and a live load of moment of 75 kN meter. And given the unit weight of soil which is 18 kN and we have here 23.5 kN per meter cube. And it is identified in the problem that the depth of the footing is located 3 meters from the natural grade line. So we have here this natural grade line to the bottom of the footing which is 3 meters, no, yung distance natin. And drinawin ko na po yung trapezoidal load sa ilalim kasi ito yung magiging soil pressure na mag-o-occur sa ating pundasyon, no. And since we have this moment, yung earthquake load nga, so magkakaroon po tayo ng trapezoidal soil pressure, no. But yung mga nakaraang video kasi, it is usually rectangle lang kasi nga we have actually loaded lang. So ibig sabihin evenly distributed yung ano natin, yung soil pressure sa ilalim. But for this moment na magkakaroon tayo ng earthquake load, may moment tayong kinonsider. So ibig sabihin magkakaroon ng uneven soil pressure, no. So kung pag ganito yung araw natin, ibig sabihin nandito yung soil pressure natin na mas malaki, no, yung maximum soil pressure At dito naman yung medyo maliit-liit na soil pressure. Okay? So, let's proceed to the design matter. Okay, so we have here this formula, QA, solution muna. We have here solution. QA is equivalent kay P all over area plus 6M all over BL squared. Okay, so this formula is for getting the getting the assumed thickness or assumed dimension of the footing para makakuha tayo ng thickness. So we have here the allowable soil pressure, which is 300 kilonewton, equivalent kay force P, which is the 600 plus the 300 kilonewton, divided by the area, which is the dimension, which is B squared, no? B squared. Ito, yung length na to na B, tapos yung perpendicular pa niya, which is also B kasi nga square ang pinag-uusapan natin dito. Plus 6 multiplied by the moment given, which is 120 dead load moment, plus 75 live load moment, all over B cube. So, si L dito is magiging B na lang din. So, we have here B is equivalent kay, lagay natin sa calculator, we have this 300 of 600 plus 300 all over alpha x squared. Alpha x squared. We have plus 6 multiplied by 120 plus 75 all over alpha x cube. Ship solve, so we have the value of 2.18 71 meter. So this will be the assumed dimension of our footing. Then para makuha natin yung assumed thickness, so we have here HC is equivalent kay 20% of the dimension, which is 2,187.1 plus 75 mm. So we could get the value, which is equivalent kay 0.20 multiplied by 2,187.1 plus 75 mm. So we have the value of 512.42 mm. Then after natin makuha yung assumed thickness, we will be getting the effective soil pressure, which is QE. QE is equivalent kay QA minus, since makikita mo lang dito ay yung lupa at saka yung konkreto, we have your unit weight of soil, height ng soil, minus unit weight of concrete, H concrete. Then lagay lang natin yung value. QE is equivalent kay QA, which is 300 kPa, minus unit weight of soil, which is 18 kilonewton, the height of soil, which is 3 meters, minus 0.51242 minus 23.5 multiplied by 0.51242. Okay, so we have here the value of effective soil pressure, which is 300 minus 18 multiplied by 3 minus 0.51242 minus 23.5 times 51242. So we have the value of 243. QE is equivalent kay 243.1817 kPa. Okay, so this will be the value of QE, and para makuha natin yung actual dimensions, so balik po ulit tayo sa formula na to. So palitan lang natin yung QA ng QE. So we have here QE is equivalent kay force all over area plus 6m all over BL squared. So we have here this QE, which is 243.1817, is equivalent kay force, which is 600 plus 300 all over area, which is B squared, plus 6 multiplied by 120 plus 75 all over B cube. So the value of B is equivalent kay, so para hindi na ako mag-type, hindi siya naka-history. So we have here 243.1817 equals the 600 plus 300 all over B squared plus 6 multiplied by 120 plus 75 all over alpha x cube. So we have here ship solve equals 2.39. So we have here the value of B, which is 2.3903 meters by 2.3903 meters. So this will be the dimension of our footing, no? Okay. Then tapos na tayo ng step 1. After natin makuha yung step 1, proceed tayo dun sa step 2, which is computing for the effective depth of the footing. Okay, wait lang para malabo yung camera. Okay, so yan. So we have here this formula. QU is equivalent kay force or factored force all over area plus 6 plus or minus 6 times factored moment all over BL squared. Okay, so dito ko na lang siguro siya isusulat pansamantala para at least ay intact pa rin yung mga solusyon natin. We have here QU is equivalent kay P factored P all over area plus or minus 6 factored moment all over BL squared. Okay? So, sulat ko yung value. We have here QU is equivalent kay 1.2 times 600 plus 1.6 times 300 all over the area, which is 2.3903 squared plus or minus 6 times 1.2 times 120 plus 1.6 ng 75 divided by 2.3903 cube. Okay? So let's put it into calculator. So we have here 1.2 multiplied by 600 plus 1.6 multiplied by 300 all over 2.3903 squared plus 6 multiplied by 1.2 ng 120 plus 1.6 times 75 divided by 2.3903 cube. So we have here the value of QU. So si positive dito is QU max and si negative dito is QU minimum. Okay? So dito ko na lang isulat. QU max is equivalent kay 326.0116. And for QU minimum, we have here this value. Change mo lang yung sign. So we have here this value which is minus. The value will be 94.0437. So KPA po yan lahat. Okay? So may QU na tayo. So after natin makuha yung QU, proceed tayo dun sa identification or getting the value of effective depth, no? So by computing it into one-way shear and two-way shear. So ilagay ko lang muna dito. So we have here this QU max, which is equivalent kay 326.0116, and QU mean, which is equivalent kay 94.0437. Okay? So, sabi ko kanina, medyo mahaba yung solusyon na to, kaya hindi magkasya, no? So, I will be erasing some of, or gagamit ako ng ibang board, but I will be explaining first, no? So, kapag sinabing si shear, one-way shear tayo, so we will be, ito kasi, di ba si critical shear is nag-occur distance d from the face of the column. So we have here critical shear for one-way shear is dalawa. So we have here this face and in this face, no? So since critical ang pinapahanap natin at yung malaking value ng shear ang pinapahanap natin, so we will be using this side na lang, no? Hindi na natin kukumputin yung sa kabilang side kasi nga maliit naman yung value dito. Kumbaga maliit yung soil pressure na mangyayari mag-occur dun sa ano natin. So we don't need to compute this one, no? So ang i-consider na lang natin pag compute ng one-way shear is itong nanditong part, no? Sana nagigets nyo to. Pero i-explain ko pa rin naman siya dun sa discussion natin. Then, yun po yung sa one-way shear. Kapag two-way shear naman po ang pag-uusapan natin, tama bang distance half d from the face of the column, no? So we have here half d, half ng d. So ma-half d siya. So half ng d magkabilaan, ibig sabihin meron akong value ulit dito ng QU and another QU in this part, no? So ibig sabihin since trapezoid siya, medyo mahaba yung solusyon at as well as medyo nakakalito siya, no? So I will be using another board para at least mas maipakita ko, but make sure na matandaan nyo ito at ito. Okay? So wag nyo po silang kakalimutan gaya ng paglimot ninyo sa mga X ninyo. Okay? Okay, so in solving the effective depth of a footing, so mayroon tayong dalawang process or dalawang formula na kailangan tandaan, which is yung one-way shear and two-way shear, no? But yung formula niya is usually pareho lang naman. VU is equivalent kay VBC, no? So sulat ko lang muna siya. So we have here one-way shear So we have here VU is equivalent kay VC. As well as sa two-way shear, ganun pa rin tayo, which is equivalent kay VU is equivalent kay VC. So I will be broaden my explanation pagdating dito kasi nga medyo tedious yung ano natin, no? So kapag sinabing si one-way shear, VU is equivalent kay VBC, tama bang VU is QU area shaded and our QU area shaded here is this one, no? So kapag pinag-uusapan si one-way shear, tama bang ang critical shear natin ay distance d from the face of the column. So we have here, kung ito yung face ng column natin, may distance d tayo. So we have here this another value of QU, tama? So kung isipin nyo kasi, di ba pag normal na computation, we have here this uniformly distributed and uniformly soil pressure distributing at the bottom of the footing. And kung makikita nyo, tama bang yung QU area shaded ay itong part na to? Ayan. Diba? So, si QU area shaded, yung VU kasi is just the volume of soil pressure. Kung makikita ninyo. So, we have here QU area shaded. Tama ba? So, yung volume na to, yung pinapakompute. Okay? So dito din sa kapag pinag-uusapan natin yung trapezoidal na soil pressure sa ilalim, kukunin lang natin yung volume ng soil pressure para makuha natin yung value ng VU. Okay? So para ma-compute natin yung value ng VU, so we need to get this one, no? Yung part na yan. So kung makikita ninyo, ang magiging itsura ng ating VU dyan is ito, itong part na to. Medyo mahaba dito, which is the value of QU max. Yan yon. And we have here this mas medyo maliit ng konti, which is itong nanditong part na red, no? So ito ay tawagin natin QU1, okay? So we call it as QU1. Then para makuha ko yung value ni VU, kukunin ko lang yung volume na yan, no? So paano ko makukuha yung volume na yan? So sabihin kong QU1 plus QU max all over 2, which is the area of a trapezoid, times yung sabihin kong ito yung x or yung distance na to. Yung distance na to, x, yung x na yan, para makuha ko yung value ng x na yan, ay tama bang ito, divide ko sa 2, makukuha ko yung kalahati, tapos yung area ng column, divide mo rin sa 2 para makuha ko yung face ng face pa lang ng column yun. Tapos minus ko ulit yung d para makuha ko yung value na to. Okay? So let's say that the value of x here is equivalent kay 2.3903 over 2 minus column dimension over 2 minus d para makuha ko itong nanditong side. So, pero yun yung explanation para dun sa one-way shear. Okay. So, para naman sa two-way shear, ganun pa rin yung natin. Para makuha natin yung area shaded, tama bang QU area shaded to, tama bang para makuha natin yung value niya is ito. Kung ito yung na-punch na nating part, dito pa yung column may distance 0.5D na 0.5D na yan. Tapang bang area shaded natin itong part na to. Okay? So para makuha natin yung pag uniformly distributed siya, tama bang yung VU natin is just the volume lang din ng natin. Volume lang din ng soil pressure sa ilalim. Okay? So since volume lang din yung hinahanap, so kailangan ko lang din kunin yung volume para doon sa two-way shear, no? So para pag ma-compute natin 'yan, kailangan ko ng para ma-compute natin 'yan. So let's say that the distance from 0.5D from the face of the column is si QU2 and another one is QU3 kasi nga magkaiba yung distance niyan, tama ba? So para makuha ko yung volume, so let's say that the volume is equivalent kay QU max plus QU min all over 2, which is the area nitong buong to, times ito, which is the distance, times yung pagganon pa. Yung pagganon niya pa. So, we have here 2.3903 squared minus yung area na to. Okay? So, we have here QU2 plus QU3 all over 2 multiplied by column dimension plus D squared. Okay? So, I do hope na nagets ninyo yan, no? So, kumbaga, yun yung konsepto niya para ma-compute natin or makuha natin yung mga value ng VU. Okay? So, balik tayo dito sa ating solving. So, let's say first that we will be computing for the effective depth using the one-way shear. Okay? Okay. So, kung one-way shear ang pinag-uusapan ko, kailangan ko ng value ni QU1. To get the value of QU1, so para makuha ko yung height na to, tama bang pwede ako mag-similar triangle? So sa similar triangle na yan, so maglalagay ako ng line dito, broken line. So we have here similar triangle. Yung triangle na tong malaki na to is equivalent sa triangle na to, no? So kumbaga similar triangle tayo. So nakarating na naman kayo dito, kaya feeling ko alam niyo naman kung paano magkaroon ng similar triangle. So we have here this value. QU max minus QU min. So, makukuha ko yung height na to. Yung height na to. All over the length. Ang length ko ito. Okay? So, para uniform yung value natin, so I will be making use this one into mm. I will be converting this into mm. So, let's say that this will be 2,390.3 equals. So, para makuha ko naman yung height na to, so we have here QU1 minus QU min all over itong distance na to. Okay? So, para makuha ko yung distance na to, tama bang kalahati plus nito plus nito? So, para makuha ko yung kalahati, we have here this 2,390.3. Tapos yung kalahati pa nito plus 400, which is the dimension of the column, all over 2. So, makukuha ko na itong distance na to. Tama? So, magpa-plus din na lang ako para makuha ko yung mismong hanggang dun sa QU1. Itong dito. Okay? So, we all know that the value of QU max is equivalent kay 326.0116 and the value of QU min is 94.0437 all over 2,390.3 is equivalent kay QU1, which is the unknown value, minus 94.0437 all over this one. So we have here 2,390.3 plus 400 divided by 2 plus D. Okay? So, para mas makuha natin yung value, so I will be kumbaga transpose. So, kukunin ko yung value ni QU1 in terms of D. Kasi nga, wala ka namang mga value pa dyan. Two equations, two unknowns ang kailangan natin. So, we have here QU1 is equivalent kay itong value na to, makukompute na natin yan. Tama ba? So, let's say that 326.0116 minus 94.0437 divided by yung ilalim, which is 2,390.3. Wait lang. 94.3037 all over 2,390.3 equals. So we have here just the value of 0. Ito, isulat ko na lang muna. Ito ay 0.0970 equals QU1 minus Q minus 94.0437 all over the value of this is pwede na natin computein. So, lagay ko na sa calculator. We have here 2,390.3 plus 400 divided by 2. So, we have here the value is 1,395.15 plus D. Okay? So, transpose, we have here the value of QU1, which is equivalent kay ito, 0.0997 multiplied by nito, lipat ko doon, 1,395.15 plus D. Ito, ilipat ko sa kabila, magkakaroon ako ng plus 94.0437. This will be the value of QU1. Okay? So, ngayon, proceed tayo dun sa value ng V ng effective depth. Okay? So, we have here VU is equivalent kay VC. And VU is based dun sa kanina. Tama bang QU1 plus QU max all over 2 times the distance. ang distance ko ay itong part na to. So, para makuha ko yan, tama bang i-change mo lang ito lahat into negative sign? So, we have here 2390.3. Kita ko ba? Ito maliit. 2390.3 minus 400 divided by 2 minus D multiplied by 2390.3 para makuha yung volume, yung perpendicular distance pa nun. Equals VBC, which is 0.75 multiplied by 0.17 lambda the square root of F prime C BWD. And we all know that this BW is equivalent kay 2390. Tama? So, pwede ko na siyang erasein. Tapos D multiplied by 1000 para makuha yung conversion factor. Okay? So, lagay ko na lang yung value. So, we have here this the value of QU1, which is equivalent kay 0.097 multiplied by 1395.15 plus D plus 94.0437 plus the value of QU max. Ang QU max is 326.0116 all over the distance, all over 2, no? Times. Pwede ko nang computein ito. So, pag kinumpute yan, ilagay lang natin sa calculator, no? So, we have here 2, baka hindi magkasya sa calculator. Computein na lang natin. So, ito ay magiging minus. So, we have here this 995.15 minus D equals 0.75 multiplied by 0.17. Lambda is 1, so hindi ko na isusulat. Square root ng 27.5 multiplied by 1000 D. Okay? So, I do hope na nasusundan niyo yung video, no? So, we have here this effective depth. D is equivalent kay. Ilagay lang natin yan sa calculator lang lahat. So, we have here this 0.097 multiplied by 1395.15 plus D alpha x plus 94.0437 plus the QU max, which is 326.0116 divided by 2 multiplied by the distance, which is 995.15 minus D equals 0.75 ng 0.17 square root ng 27.5 multiplied by 1000 D. Yung 1000 po dyan is the conversion factor para maging yung MPA ay ma-convert. Ship solve equals. So we have here 302. The value of this is 302.7690 mm. So this will be the value of the base sa one-way shear tayo. Okay? Okay. So, tandaan lang natin kung anong value niyan. So, one-way shear, D is equivalent kay 302.7690 mm. Okay? So, let's proceed in computing effective depth using the two-way or the punching shear naman tayo. Okay? So, i-erasein ko na lang to. Dito na lang din ulit ako magsasolve para at least ay tuloy-tuloy ang natin. Okay, so in-explain ko na rin siya kung paano kanina. So, kailangan ko lang makuha yung value ni QU2 and QU3, which is ito si QU2 and si QU3. So, gaya ng ginawa natin kanina sa pagkuha ng QU1, kailangan ko lang din mag-similar triangle. Okay? So, we have here this value of QU max minus QU min all over 2390.3 equals. So, unahin ko muna si QU2. No? So, we have here QU2 minus QU min all over yung distance ko is equivalent kay, tama bang itong distance na to? Okay? So, para makuha ko itong distance na to, tama bang itong dimensions na to, kalahati, tapos kalahati ng column, so makukuha ko itong distance na to. Tapos magpo 0.5d na lang ako dito, minus 0.5d. Okay? So, tama bang ang distance na to ay 900, yung kanina, 900, solve natin yung ito, 995.15. Okay, so itong distance na to ay 995.15. So, para makuha natin siya, 995.15 minus 0.5 ng d. Okay? And we all know that this is 0.097, tama? So, pwede ko nang sabihin the value of QU2 is equivalent kay 0.097 multiplied by this one, 995.15 minus 0.5d plus 94. Ito, ilipat ko yung Q min dun sa kabila. 94.0437. Okay? Then, balik ulit tayo sa QU max minus QU min all over 2390.3 equivalent kay QU3 minus QU min all over the distance will be this one, no? So, kung ito ay 995.15, so magpa-plus 400 lang ako para makuha ko itong distance na to. Tapos magpa-plus 0.5d ako para makuha ko itong distance na to. Tama? Tama. Okay. So, we have here this 995.15 plus 400. Okay, so we have here 1395. So we have here 1395.15 plus 0.5 ni D. Okay? So ito, gawin ko lang ulit ng ganun. No? So we have here QU3, which is equivalent kay 0.097 multiplied by 1395.15 plus 0.5 ni D plus 94.0437. Okay? So, tama bang yung formula ko kanina ay para makuha yung VU, which is the volume, is QU max minus QU min plus QU min all over 2 times yung 2.3903 squared minus yung QU2 plus QU3 all over 2 times yung 400 plus D squared. Okay, so kukumputin ko na yung QU2 plus QU3 by solving this. Huh? Okay? So, balik ako dito. QU2 plus QU3 is equivalent kay. Okay, so check nyo yung QU2 at check nyo si QU3. So, pwede ko nang tanggalin yung 0.5D dito at 0.5D dito. Na? So, kasi negative 0.5D, ito minultiply ko doon at ito minultiply ko dyan is masisiro yun. Tama ba? So, ang gagawin ko na lang, ito, pagsasamahin ko ito at ito, tapos ito at ito. Okay? Okay. So, I do hope na nag-gets ninyo ha. Pero isusulat ko sa calculator para at least mas maintindihan ninyo. Okay? So, isulat ko muna ito. 0.097 multiplied by 995.15 plus 94.0437 plus yung sa ilalim, we have here 0.097 multiplied by 1395.15 plus 94.0437. So we have the value of 419.9465 kPa. Okay? So, proceed tayo dun sa formula. Ito ay two-way na to ha. So, kaya na to, two-way here. So, sa two-way shear, we have the same formula. VU is equivalent kay VC. And VU is, in-explain ko na kanina, we have here QU max minus QU min all over 2 multiplied by the area, which is 2390.3 squared minus QU2 plus QU3 all over 2 multiplied by 400 plus D squared equals 0.75, which is phi, times VC is equivalent kay 0.33 lambda the square root of F prime C BOD. Okay? So, lagay ko lang to ulit. Plus pala to. Kasi nga, trapezoid tayo. Okay? So, lagay ko yung mga value. So, we have here 326.0116 plus 94.0437 all over 2 multiplied by 2390.3 squared minus QU2 plus QU3, alam niyo yung value niyan is ito. So we have here 419.9465 divided by 2 multiplied by 400 plus D squared equals 0.75 multiplied by 0.33. Hindi ko na ilalagay yung value ni lambda kasi nga 1 pa rin siya. Square root ng 27.5. PO is equivalent kay 4 times 400 plus D. Yung D is 1,000 D. So, yung 1,000 ulit is conversion factor, no? Para ma-convert yung MPa. So, ilagay ko lang yun sa calculator. We have the value of D is equivalent yan. So, 326.0116 plus 94.0437 divided by 2 multiplied by 2390.3 squared plus minus 419.6465 divided by 2 multiplied by 400 plus D squared equals 0.75 multiplied by 0.33 the square root ng 27.5 multiplied by 4 times 400 plus D multiplied by 1,000 D. Sana umabot. Okay, yan. So, equals. So, we have the value of 301.252 mm. So the value of effective depth for two-way shear is equivalent kay 301.252 mm. Okay? So ang gagamitin natin is 302, no? So thickness is equivalent kay 302 plus yung concrete cover plus yung bar diameter. Okay? So I do hope na nasundan nyo to, no? So magtanong na lang kayo dyan sa video kapag mag-comment kayo, no? Pag hindi nyo nasundan. Okay, so nasa step 2 na tayo. Tapos na tayo na step 2. So mag-step 3 tayo. So bago tayo mag-step 3, kunin ko muna yung actual thickness ng footing. Okay? So we have here thickness is equivalent kay 302.7690 plus tama bang ito yun? Concrete cover is located at this point, 75 mm. So from the face of the bottom bar up to this point is equivalent kay 75 mm. And consideration ko sa aking design, depende naman to, no, sa iba. So from the center of the top bar papunta doon sa ano is the D. Okay? Sa ibang video, parang may napanood ako sa ibang video is dito sa center, no? Ito. So it depends naman sa nagde-design 'yan, no? So kahit saan po diyan basta ang alam ko kasi sa sentro siya ng bakal, no? So siguro ang consideration niya is may top bar at bottom bar. So the middle of the top bar and bottom bar ang ginawa niya. But for me, I use the top bar, no? Kasi para mas malaki pa yung magiging thickness kasi nga magkakaroon ka pa ng additional 0.5D, no? Kung nag-start ka diyan sa kung ang consideration mo is nasa top bar yung effective depth, no? Kasi kung halimbawa dito ka sa gitna ka nagsimula, so magkakaroon ka lang ng plus D. Pero kapag dito ka nag-start, magkakaroon ka ng 0.5D. So ibig sabihin medyo sa design ko naman safe pa rin naman siya, no? Kung in either way. Okay? So para naman sa mga estudyante ko, para at least uniform yung ano natin. So let's consider na nasa mid ng top bar yung effective depth natin. Unless specified sa problem or sa exam kung saan yung location, no? So dito, dyan tayo sa mid ng top bar. Okay? So ibig sabihin, meron pa ako ditong 1.5 bar diameter. Okay? So we have here this 1.5 multiplied by 20 mm kasi 20 mm ang gagamitin natin plus 75 mm. So the thickness will be equals thickness is equivalent kay, lagyan natin sa calculator, we have here 302.7690 plus 1.5 ng 20 mm plus 75 mm. So we have here 407. So we have here thickness is 407.7690 mm. Okay? Okay, so after natin makuha yung thickness, so proceed tayo sa pagkuha ng steel requirements. And again, sa pagkuha po ng steel requirements, we will be having two moment, no? Kasi nga, yung moment, pag ganito, so kung makikita nyo kasi, ang volume niyan ay ito. Medyo mahaba yun dito, tapos meron ditong maliit. So, kapag kinat ko yung ganyan, tama bang ito makikita ko? So, kapag kinat ko naman pa ganito, tama bang ito yung makikita mo na value? So, ibig sabihin, iba yung volume na to at iba naman yung volume dito. Okay? I do hope na na-picture out nyo. Engineering naman kayo, kaya alam ko marunong kayo mag-imagine dyan. No? Drinawin ko na rin naman siya para hindi na kayo mag-imagine. Okay? So, unahin ko munang isolve yung pag-cut ng pagganito para at least makita ninyo. Okay? So, still requirements tayo. Still requirements. Okay. So, sa still requirements, unahin ko to. So, ibig sabihin from the face of the column tayo. Ibig sabihin may another QU ulit tayo. No? So, from this face, so let's assume that this will be QU4. Okay? So, sabihin ko si QU4 yan. So, para makuha ko yung value ni QU4, let's say that QU max minus QU min all over the distance, which is the dimension 2390.3 equals QU4 minus QU min all over the distance. Ang distance ka ito. Tama? So, para makuha ko yung distance na yan, tama bang yan ay yung 13 kanina? 1395 ata yun? Check lang natin. 1395. Yan. 1395.15. Tama ba ito? So, ilalagay ko lang 1395 to. 1395.15. Okay, so lalabas the value of QU4 is equivalent kay, tama bang ito ay 0.097? So, we have here 0.097 multiplied by 1395. 1395.15 plus yung QU minimum, which is 94.0437. So, the value of QU4 is equivalent kay 229.3733. Ay, 1395. Wait lang. Check ko yung solution. 0.1395.15.097 0.1395 plus 94.0437. Okay. Equals. So, we have here 229.3733. Okay? So, since may value ka na ni QU4, tama bang kukunin ko yung MU. MU is equivalent kay phi RU BD squared. And si MU is the moment of this one, this area, no? So, lilinisin na natin siya para at least makita ninyo. Yung moment nitong area na to, tama? So, kailangan ko lang kunin yung moment, which is the MU nga. So, para makuha ko yung MU na yan, so pwede kong sabihin, ikakat yung trapezoid na pa ganito. Ito si QU4, QU max. Ito si QU4. So, pwede kong gawin na ito. Na? So, may dalawa akong triangle para makuha ko yung moment dito sa part na to, moment. Okay? So, para mapakita ko sa inyo kung paano yan, ito yan. So, we have here, unahin ko si QU4, no? So, QU4 multiplied by the distance. Ang distance na to is equivalent kay yung distance na to para makuha yan ay 995, tama ba? So, multiplied by 995.15 all over 2, which is the area of the this triangle. multiplied by, tama bang ang centroid niyan ay nasa 1/3? 1/3 multiplied by the distance, 995.15. Plus, QU max naman tayo. QU max all over 2 multiplied by the perpendicular distance, 995.15. Okay? Multiplied by, tama bang dito yung pointed vertex natin, ibig sabihin 2/3 yung distance, no? So we have here 2/3 ng 995.15 multiplied by yung perpendicular distance, which is 2390.3. Okay? So, ito ay pangkabuuan tong 2393. Okay? Equals 0.9 RU B, which is 2390.3 times D. Ang gagamitin natin D ay yung 302. So, 302.7690 squared. Okay? So, we have the value of RU, which is equivalent kay, lagay natin sa calculator. So, we have here the value of QU4, which is equivalent kay 229,229 multiplied 0.37 0.3733 multiplied by 99995.15 squared. Is-squared ko na ha. Ito. All over tong 2 times 3 ay 6. All over 6 plus QU max, which is 326.0116 multiplied by the distance ulit, 995.15 quantity squared divided by yung 2 at yung 2 dito ay makakancel, so we have here divided by 3 equals, hindi ko na ilalagay yung 2390 kasi nga makakancel din naman ng 2390 dito. So we have here 0.9 RU, which is alpha x, multiplied by 302.7690 squared, and again, huwag kakalimutan yung 1000 for the conversion factor. So we have here multiplied by 1000. So we have the value of R, which is 1.7633 MPa. Okay? So para another board tayo. So the value of RU, which is equivalent kay RU, which is equivalent kay 1.7633 MPa. So check for rho, no? So we have the value of rho, which is 0.85 F prime C over Fy multiplied by 1 minus the square root ni 1 minus 2 RU over 0.85 F prime C. Okay? Diretso ko na lang sa calculator para at least hindi masyadong maaksaya ng space. Okay, so we have here 0.85 F prime C, which is 27.5 divided by 415, which is given dun sa ating problem, multiplied by 1 minus the square root of 1 minus 2 RU. RU is equivalent kay 1.7633 divided by 0.85 ng 27.5. equals. So we have the value of 0.0044223. Okay? Then check for rho minimum. Rho minimum is equivalent kay 1.4 divided by Fy. So 1.4 divided by 415 equals 0.003373. So ibig sabihin si rho is greater than rho minimum, but we need to check for rho max, no? So si rho max is equivalent kay 0.75 rho balance, and we all know that rho balance is equivalent kay 0.85 F prime C beta 1 times 600 all over Fy times Fy plus 600. Okay? So we have here rho max is equivalent kay, diretso ko na sa calculator para at least makita nyo, 0.75 ng rho balance, which is 0.85 F prime C, which is 27.5 times beta, which is 0.85. So beta po is nagvavaries po yan, no, pagdating sa F prime C. So since ang F prime C natin is 27.5, less than 30 ata, so 0.85 ang gagamitin natin, times 600 divided by 415 multiplied by 415 plus 600. So we have here the value of rho max, which is equivalent kay 0.0212. So ibig sabihin rho minimum is less than rho, and rho is less than rho max. Ibig sabihin gagamitin po natin yung rho. Okay? So since gagamitin natin sa rho, we could continue to formula AS is equivalent kay rho BD. So we have here AS is equivalent kay 0.00423 multiplied by B, which is 2390.3 multiplied by D, which is 302.7690. So we have here AS is equivalent kay, lagay sa calculator, we have here 0.004423 multiplied by 2390.3 times 302.7690. So we have here the value of AS, which is 3,200.9638 mm squared. And to get the value of number of bars, so we have here AS all over A bar. So ito ay 3,200.9638 divided by pi times 20 squared all over 4. So number of bars is equivalent kay point at 3,000 pala, 3,200.9638 divided by pi times 20 squared divided by 4. So we have here 10.1890. So let's say yan ay 11 pieces. Okay? Then, to get the spacing is equivalent kay 2390.3 minus 150 all over 11 minus 1. So, we have here spacing is equivalent kay 2390.3 minus 150 divided by 10. So we have here the spacing of 224.03, and we could say that this will be 220 mm. Round down po tayo kapag spacing ang pinag-uusapan. Okay? So yan po ay yung sa isang side, no? So kung ito yung ano natin, since ang cut natin ay pa ganito, ibig sabihin itong bakal na to ang kinukumpute natin. So yan ay 11 na piraso na may distance na 220 mm. So ngayon, kukumpute natin yung bakal pa ganito, no? So ibig sabihin ang cut natin ay pa ganito dapat. Okay? And in-explain ko na kanina kung paano magiging volume ng moment, no? So another board pa ba tayo? Another board na lang tayo. Dito na lang, erasing ko na lang. So another board. Ito. So we have mu is equivalent kay phi ru bd squared. And to get the value of mu, tama bang ito yon? Ito yung kinat natin na side. Tapos ito yung yan yon. So ibig sabihin meron akong QU max dito at meron akong QU min dito. Tama ba? So kukunin ko lang yung volume na yan para i-moment ko. So magiging distance nito pag ganyan, multiplied pa pag ganon para makuha ko yung moment talaga. Okay, so para makuha yan, yun lang. We will be using QU max plus QU min all over 2. Ito. Kunin ko yung area na to. Multiplied by 2390.3. So, itong area na to. Na yun. Tama? Multiplied by itong perpendicular distance na to, which is 995.15. Multiplied by yung kalahati nito. Kasi kung ang makikita mo ay pag ganon, twist mo to pag ganon, makikita mo na lang ay pag ganito na rectangle at yung force is nag-a-act sa gitna. Tama ba? So, ibig sabihin, multiplied by the distance, perpendicular distance, which is ito. Tama bang yan ay, itong kabuuan kasi ay 995. So, we could see that 995.15 divided by 2. That will be the moment, mu, equals 0.9 RU, B, which is 2390 ulit, 0.3, times D, which is 302.7690 squared. So, makukuha natin yung value ng RU dyan. Okay? So, erasing ko lang to. So, lagay ko na yung mga value dyan sa calculator. So, we have here QU max, which is 326.0116 plus 94 point value ng QU min 94.0437 divided by 2. So hindi ko na isusulat itong 2390. Diretso na ako sa 995.15 squared. Squared ko na kasi para naman siyang 995 divided by 2. Then equals 0.9 alpha x multiplied by yung 2390, makakancel na nga to. So, diretso ako sa 302. 302.7690 squared times 1,000 ulit. So, si 1,000 is the conversion factor. Okay? Okay. Shift solve equals. So, we have the value of RU. RU is equivalent kay 1.2605 MPa. Okay? So, para ma-compute natin ulit, compute for rho, which is 0.85 F prime C all over Fy times 1 minus the square root ni 1 minus 2 RU over 0.85 F prime C. Okay? So, the value of rho is equivalent kay, lagay lang ulit natin yung value ng rho. Ito ba yan? So, hindi na natin ma-history. So, ilagay ko na lang ulit. So, 0.85 F prime C, which is 27.5 all over Fy, which is 415 multiplied by 1 minus the square root of 1 minus 2 RU. RU will be 1.2605 divided by 0.85 F prime C, 27.5. So we have here 0.003124 the value of rho, and check natin for rho minimum, at ang value ng rho minimum natin ay equivalent kay kanina 0.003373. Okay, so gagamitin natin is si rho minimum kasi nga mas malaki yung rho minimum kay rho, no? So AS is equivalent kay rho min BD. So we have here AS is equivalent kay 0.003373 multiplied by 2390.3 times 302.7690. Okay? So we have here AS is equivalent kay, medyo pabilisan na lang, mapangit na ng sulat ko. So we have here 0.003373 multiplied by 2390.3 multiplied by 302.700 7690. So we have here the value of 2,441.0696 mm squared. And to get the value of number of bars, so we have here 2,441.0696 all over pi times 20 squared all over 4 to get the value of number of bars. Okay? So to get the value of number of bars, we have here 2,441.0696 divided by pi times 20 squared over 4 equals, so we have here 7.7702 pieces. So let's say this will be 8 pieces, and for the spacing will be 2390.3 minus 150 all over 8 minus 1. So spacing is equivalent kay, lagay natin sa calculator, 2390.3 minus 150 divided by 7. So we have your spacing of 320.0429. So let's say 320 mm. Okay? So this will be the value of the spacing doon sa ating computation. Okay? So that will be the total computations nung discussion kanina. So medyo mahaba siya, no? And I do hope that this video will help you to understand, no? Kasi isang problem lang siya pero medyo sobrang dami ng kino-compute, no? And one error from the top, may domino effect siya. So hindi na siya dapat pagpatuloy. Once na nagkamali ka na, dapat titigil na, no? Pero yun nga, kailangan mo magka-points kapag nag-exam, no? So aralin niyo po din siya, no? Kasi nga medyo kahit kabisado mo na siya, medyo nakakalito pa rin siya. Pero yun nga, as part of online learning nga, kasi nga hindi na kaklase ng face-to-face, medyo mahirap para sa inyo mga estudyante na makaintindi ng ganitong subjects, no? Kasi nga hindi naman kayo basta-basta makatanong ng diretso, kasi nga minsan nahihiya yung iba naman ayaw na magtanong kasi nga baka mapahiya, no? But on my video, you can message me dun sa chat box or sa comment section kapag medyo malabo or hindi nyo naintindihan, so I could explain my side, no, na ganito yung ganyan. So actually may second problem pa ako, but it is the yung exam na ng estudyante ko, no. Papakita ko lang din sa inyo yung solusyon, but since parang mag-abot na ng 1.5 or 2 hours na yung video, so I could next video na lang siguro yung solution for the quiz 1, no? And so yun. So I do hope that this video will help you to gain more knowledge when it comes to dun sa subject na foundation and retaining wall design. So kung may mga questions kayo at medyo malabo, so you can message at through chat box, no, dun sa video. Then pag may corrections, okay lang din na makorek ako, no? Hindi naman tayo perfecto, no? So possible magkamali din ako, so you can correct me, no, in a good way naman yan, no? Para tayo natututo na correct naman. Okay? So kung I do hope na nag-iingat tayo sa panahon ngayon, at sana kahit ganito yung sitwasyon natin ay may natutunan pa rin tayo, no? So please, kumbaga ay lahat ng mga ginagawa ng faculty is na gumagawa sila ng video para lang maipaabot sa inyo yung learnings. So sana suklaan nyo din, no? So aralin at panoorin nyo din yung mga ginagawa nilang video. So yun, keep safe tayo, ingat tayo, huwag tayong lalabas kung hindi naman importante, at laging maghugas ng kamay at maging malinis sa ating katawan. So yun, once again, kung hindi pa rin kayo nakaka-subscribe, please subscribe my YouTube channel, no? So yun, paki-like na lang din yung video or ako ang i-like ninyo. Okay? Joke lang po ulit yan.